Okay, so here's my first video where I'm actually looking at you guys face to face. We're talking about Chapter 3, Section 2, angles formed by parallel lines and then a transversal that gets cut through that parallel line. Your objective is what you should be able to do by the end of the lesson, which is prove and use theorems about angles formed by parallel lines and a transversal. Right now, I want you to pause the video and write your essential question before you forget so that you can receive those points when you get to class. Okay, you should have paused the video, you should have your essential question. Now let's get started. Craziest circle map in the world. It's very blobby, but there it is. Corresponding angles postulate, that's the first one we're going to talk about. Basically, it says that if I have two parallel lines, and you know that they're parallel because they're marked with these little red arrows, the ones that are corresponding are the ones that match up. So angle 1 and angle 3, if I were to pick this section up and lay it right on top of this section, those would be one right on top of the other. So those are the ones that match up, they're corresponding. 5 and 7 are corresponding, so they're the bottom left, bottom left. 6 and 8 are corresponding, bottom right, bottom right. 2 and 4 are also corresponding, so top left, top right, and top right. Over here, we have a sample problem that I've already worked out for you. But in this corner, we have 4x plus 22 degrees, and in this corner here, we have 5x degrees. Hopefully you can see that. I'm not sure that you can. And in this bottom corner here, it's 70 degrees. Oh, I forgot my degree symbol. So 70 degrees. There's a few things that you can do. You know that this is a linear pair, so you can have 4x plus 22 degrees plus 70 equals 180. Or you know that, well, these are vertical, so you know that 70 is also here, and you can add that one plus that one to get 180, which is what we just did. But since we're talking about corresponding angles, let's use the postulate. We have 4x plus 22 equals the 5x, because these angles are the ones that are corresponding. Top right here and top right here as well. So that's what I did. I set my 4x plus 22 equal to the 5x, subtracted 4x on both sides. I got 22 equals x because 5 minus 4 leaves me with 1x. And then I substituted the 22. You could have picked either one. I chose the 5x because that was shorter. 5 times 22 gives me 110, which means that this angle is 110 and that angle is 110. Some of you figured out right away that I could have just subtracted 180 from 70 and figured out what the angle was. But sometimes you're going to have to find x and not just the angle. Alright, so the next one. If two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. That's the alternate interior angles theorem. So that means, again, parallel lines. Interior means the inside. So inside the parallel lines, we're just looking at these four angles here. Alternate means on opposite sides of the transversal. So 1 and 3 are on opposite sides of that line that cuts through, and they're both on the inside of the parallel lines. 1 and 3 are congruent. 4 and 2 are also congruent because they're on opposite sides of the line that cuts through, and they're on the inside. I'm going to move this down. That's better. Okay. Alternate exterior angles theorem. That's the next one. Talks about exterior means outside, so we're talking about outside the parallel lines. Alternate still on opposite sides of the transversal. So 5 and 7 are on opposite sides of the transversal. Those two are congruent, and they're on the outside. 6 and 8 are on opposite sides of the transversal, and they're on the outside, the exterior. So that's where we get this from. All right, last one. Same side interior angles theorem. Same side instead of alternating. And interior, we're talking about the inside of your parallel lines. So 2 and 3 are going to be supplementary. So that means they add up to 180. 2 and 3 add up to 180. 1 and 4 also add up to 180. Alright, so this is where we do the math. There's a lot of stuff that you just learned. We're going to apply it. If you take a look at this, I'd like you to come up with things that you think will work to set up an equation. So I want you to pause the video right now, see if you can figure anything out. If you don't know what I'm talking about, then you're just going to keep playing the video and you're not going to pause. Okay. So some of you might have thought that this angle here and this angle here I can set equal to each other. That's not going to work because these two lines, line P and Q, are not marked with the little red arrows, so we don't know that they're parallel. These three lines here are marked with the red arrow, so all three of those are parallel. So when I'm talking about alternate exterior, alternate interior, all those theorems we just learned about, we have to talk about this as a transversal and these three parallel lines. And then we're going to ignore the top part. And then we can look at the top part and ignore the bottom part. These are our parallel lines still, but this is our transversal. So we can create something with this 55 and this top right corner of this section here, and this 5x minus 4y in the bottom left-hand corner of this section here. Now this, I don't know if you can see the colors, but I tried to highlight this in orange and this in orange as well. They're both on the inside of these two parallel lines, and they're on alternating sides. So alternate interior angles tells me that this measure is going to be equal to this measure. So I've got 55 is equal to 5x plus 4y. Now looking at the bottom portion, I have this 60 degrees here, bottom left, and this 5x plus 5y, again bottom left. So these are corresponding. If I were to pick this section up, slide it over, move it right on top of that one, these two are going to line up. Corresponding tells me that that 60 degrees is going to be equal to 5x plus 5y. Now some of you are saying those two equations are still really difficult to solve because they have two different variables. Because they both have the same two variables, we can create a system of equations and use that to solve for the missing values. So if I have this here, I see the 5x and the 5x are the exact same number, so I can multiply the bottom one by a negative and then they'll be opposites. So I'm going to multiply this bottom one here, or you could multiply the top one, doesn't matter, by a negative 1. When I distribute that negative 1 to the entire problem, I'm going to do it in the same step right here so I don't run out of room. I have a negative 60, a negative 5xy, and a negative 5y. I just distributed the negative to the entire equation. Now I have a positive 5x up here and a negative 5x down here. So when I add my system, these are opposite pairs and they're gone. They make 0. Then I have 55 plus a negative 60, which is going to give me a negative 5. Bring down my equal sign. 4y plus my negative 5y gives me a negative 1y. Still solving for y, I have to get that variable by itself. Going to divide both sides by a negative 1. Negative 1 divided by a negative 1 is a positive 1, so I'm left with 1y equals negative 5 divided by a negative 1 is a positive 5. Now that we have y, we just need to substitute back into the other problem and find x. So I'm going to pick, it doesn't really matter, I'm going to pick this one here. I have 5 times x plus 4. Instead of y, I'm going to put the 5 that we just found. and we said that one was equal to the 55 over here. 4 times 5 gives me 20, plus, I have that 5x right there, equals 55. You subtract 20 from both sides, you get 35 equals 5x. Divide both sides by 5. We get x equals 7. So we were able to find both missing values by using the theorems that you learned in this chapter. I hope that's helpful. Maybe watching the video over again before you write your summary in case I went too fast would be a great idea. And I'll see you again when we do 5-3.